Good afternoon. I'm Janet Schwartz, and I'm with the University of Kentucky Facility Information Services Geospatial. This session is Model QA/QC process, how OSU and WMU ensure that they're receiving good Revit models, and it will be 45 minutes approximately.
Thank you. Hi, everybody. I'm TJ. I'm with CADD Microsystems. I'm going to kick us off here a little bit and talk a little bit about kind of these tools that these two schools are using. I'm going to hand it over to Joe Porostosky. You guys have seen Joe. He's, yes, Chuck, do you have a question? Already. Hi, Chris. Welcome to the presentation. So I'll hand it off to Joe. Joe's going to walk through the process that OSU is using to do model QA/QC. He'll hand it off to DeVon. DeVon will talk about the process that Western Michigan is using for QA/QC. Some very interesting stuff. So I may make some statements in here about some future software that Autodesk is coming out with because we have a big release coming up, actually, for some of these tools. These guys are going to show the current versions of these tools, but there are some new versions coming out very soon. So this essentially says, I'm going to tell you about these tools. Don't make any business decisions about these tools. If you make business decisions about these tools, I'm not liable. Autodesk isn't liable. Okay, so we're going to talk a little bit about why model checking is important, talk about two of the tools these guys are using, and then I'm going to hand it over to them, and then we'll do some Q&A at the end. Okay, so model checking. Why do you want to check your models? Three big reasons, right? First off, you're asking for models. Hopefully you have a set of BIM requirements in place. If not, please come see me. And those BIM requirements say how you want those models. If you get a model that isn't formatted the way you want it, you're not going to be able to do anything with that data. So it's very important that you have a set of standards and then you check against those standards. If done right, this is not a punitive issue. This isn't, oh, you just went through all that work and handed me the model and I just told you 1,000 things that are wrong with that model. This should be an iterative process. This should be something where the way the model checking software that you're going to see is set up is the authors of those models, the architects, the engineers, the contractors, they can actually start using this software from day one with their standards that they need to follow and continually check them as they go along. So when it comes to submission time, they don't have to scramble and figure out 1,000 errors. And so that's why it's important for model checking. That's part of putting the onus on them. You as an owner don't need to spend all this time checking models. We just heard in the presentation before this, OSU was spending upwards of a week checking models before they put model checking into place. And now they can do it in minutes and hours instead of a week. From an owner standpoint, data is more important than graphics. That's the way it is. It takes, in general, it's about 10% of design and construction, and about 90% of the total cost of a building over its life is with operations, and most of operations is handled through data. Graphics are certainly important, but not nearly as important as the data. So a lot of this model checking you're going to see today is around the data. Did they put data in the right place? Is it in the right format? And those are things that can be very quickly done with automated tools. So they're going to talk about a couple tools today. One of them is the classification manager. The advantage of the classification manager, let me back up. All of these tools are free. Anybody who has Revit can get these tools. They're all Autodesk tools. You can download them from the BIM tools website, which I will show you a link to here in a second. So the classification manager is a great tool to be able to assign classification values to elements in the model. And sometimes it's very standard classification systems like uniformat and master format and so on to classify these elements in the model. And sometimes it's just because you have a pick list. I have a particular field that I want attached to this piece of equipment, and there's only 10 values you should ever put in that field. And the classification manager can help you do that. And you can hand it to people and give them your database, which is just done in Excel. It's very simple. And they can go in and just pick from the list what they want to assign to that piece. The next part is the model checker. So the model checker, the Autodesk model checker for Revit, again, a free tool. And what this allows you to do is to set up checks within your model. It's very good at seeing if something was modeled or not modeled. It's very good at seeing if something was duplicate modeled. Are there things on top of each other? I made the joke yesterday, I think a lot of people felt the pain there of, have you ever been in Windows Explorer and you accidentally grabbed a folder and moved it somewhere into some other folder, and now you have the duplicate, or you have it moved and you don't even have any idea where to look to begin with? This is a great tool for that. Just look through the model and find where somebody accidentally put 2 columns on top of each other. And they didn't even realize they did it, and I won't even know until I do takeoffs later on. But it's also really good at checking data. Is there a parameter, a data field, sitting in that model that you're expecting to see? Is it attached to the right elements? Is there data in that field? Is the data in that field formatted a certain way? You'll see that OSU has a very strict rule on how it numbers the rooms so that it can follow a sequence on it, and it can look for that. It can even check and say, is the data in that field match this list of available or of allowed items? And so the model checker can be set up to do all of that. The model checker comes with an authoring tool called the Model Checker Configurator that's also free that lets you build these checks yourself. When you open up the model checker, for the first time when you install it, you'll actually see Ohio State's, you'll see Western Michigan's sets of checks in there, you'll see Penn State's, you'll see the Army Corps of Engineers, you'll see all these other ones that we continually add to it to make publicly available for everybody. You can download those, you can steal the checks out of it, you can make your own checks, you can compile them all together into your custom piece. It's all XML based, which is open source, so it makes it very easy to build your own set of standards, build against your own set of standards. All right, here's where you can get those tools, BIMinteroperabilitytools.com, to say it very slowly. And you'll get the classification manager, model checker configurator. We also have some other tools on there, the enhanced DWG exporter. Somebody just asked me earlier, Janet, I think it was you, about their standard is to only show the outside edges of walls in CAD files. So when I export from Revit, can I not show the chipboard layer lines? And out of the box Revit, that can be difficult, and the enhanced DWG exporter can help you with that. And then of course, COBie extension. If you have a COBie deliverable, this is the best way to get it. All right, I'm going to turn it over to DeVon. DeVon's going to walk through his process of QA/QC.
Thank you, TJ. Hello, everyone. My name is DeVon Miller. Building commissioning specialist for Western Michigan University. So I'm going to go over some of the things about what we're doing. First thing I'm going to do is play a little short video, kind of give you those a feel for our campus. If you haven't been to Kalamazoo, I always go by Mitten, I guess. So if you're looking at Michigan, we're about, well, I'm going to do it here. So we're about right there, or the way, you could this way. So we're about right here. So facing me and stuff, yeah. So if you were facing you, but we're about right here in Kalamazoo. So I'll play this while that plays. It's basically a drone flyover, kind of gives you a visualization for our campus. I'll give you some quick facts about Western. We have roughly around 439 employees for facilities management. We have 8 million square feet of, I'm sorry, okay. Can you hear me better now? All right. About 8 million square feet of campus, 1,200 acres, 49 miles of utilities, 39 miles of sidewalk. We export about 72 kilowatt of electricity, and then we produce about 510 million pounds of steam. We have roughly about 170 buildings on campus. More than you guys know, most of our buildings on campus, all our existing buildings are modeled, utilizing Revit. We've added some pieces of equipment, so I'll be kind of give me a firsthand view of what we did, and then kind of show you why we transitioned to the model checker. There was one project specifically that really helped drive that decision to go that route, and I'll kind of go over some facts and figures why that was. So as soon as this stops playing, I'll move forward. Let's go. There we go. stuck on this video. All right. Technology, you gotta love it. There. So I think many of you that have seen my presentation in the past kind of saw our journey, how we were going through adding equipment to our models and then assigning enriched data, certain parameters that were important to us. That's kind of what we're illustrating here. Many of you guys know that we were able to sync both our databases, our BIM database with our CMMS, and we can push data back and forth between Revit and our CMMS system. We use WebTMA. Now I'm giving you more of a behind the curtain type of thing for Wizard reference. So now you can see how we set up our BIM database within TMA. So here you kind of see how we can, we have our template set up so we can define mechanical equipment, electrical equipment, plumbing fixtures, electrical fixtures, fire alarm devices, lighting fixtures, specialty equipment. Specialty equipment would be elevators, coolers, freezers, things of that nature. It's basically configured to how Revit classified their families for a piece of equipment. If you guys are familiar with VFDs, variable frequency drives, that family type in Revit is electrical fixture, not electrical equipment. So we have all those things classified so that now when a building is being modeled, it will easily push into our CMMS because it knows what that family type of that equipment is. So when we about to do a new design, one of the things I do is I put together a spreadsheet for our AE firms as well as our CM, basically creating all the tag numbers for all the mechanical, electrical, and plumbing and lighting fixtures for the project. And this kind of gives you a snapshot. So I give them the base information. So I give them what our asset tag ID information is, what type of equipment is, subtype, where the room location is, the description, and basically show them what, as you can see here, I show them basically how the drawing classified that equipment. So the architect might call that air handler 2, but I call that 140AH AHU2. That's how we define that piece of the asset. It's based on the building number. AH is air handler. AHU is how the unit is labeled on the drawings. Then once the closeout is handed over to us, the model is handed over to us, we basically push that information from Revit into TMA. So that kind of just shows that reference there. So one of the challenges I had is with our housing project. We built 2 res halls, 94,000 square feet in 2015. And when I went to go push that information into our CMMS database, I had to create a 16-page error report. So I had to go through each one of them, because when I go to push it at TMA would give me a list of errors. And if you can think, each room had its own fan coil unit. Once it errors in one room, it's going to error in every single room. So this is one of the reasons why we wanted to go to the model checker, because it took a lot of my time to go through and create a 16-page report and tell them everything that failed. So this is the project that led us down that road. So working with Autodesk, Chuck, and with TJ, we were able to simplify that process. I'm kind of going through that right now, how we did that. This guy gives you an idea of what some of those areas were. Like right here, manufacturer. One of the problems is anytime you have a new manufacturer added, if that manufacturer is not in your CMMS, it's going to error. So I have to make sure that new manufacturer has been incorporated into our CMMS system. Same thing, the location got wrong. We have heat pumps, and for some reason they put a wrong room number for the heat pump, error, because it doesn't recognize the location. So those are some of the errors I got. So one of the things we did is we created a database, or kind of for CAD Microsystems, excuse me, I'm kind of nervous, for TJ and his team, kind of defining what the different values or different critical information that we had in our CMS, so they were able to kind of help create that model checker for us that is custom for Western. So as you can see in some of these, we have character limitations. So like for a filter, we have character limitation of how many characters it can put in the filter field in our CMMS and so forth. And then we gave them all the list of different equipment types that we have. So all that was given to them as in a matrix so they can help create the model checker that's custom made for us. The next step we did is I put the model checker into our BIM execution plan. So now anyone that does a project for us, and it's right here under quality control, the GCCM is going to be responsible for running the model checker on the model before they turn it over to us to make sure that it's error-free. And the other thing that we did is we added another another quality assurance is we had our commissioning agent involved with reviewing the as-built model as well. So I'm just going to run through how we use a model checker. So once TJ kind of showed you how you go to download it from the BIM interoperability tools, you click on Western. They go to open it. Select Western, Michigan University, and then you just choose what I want to check. So in this case, they're going to click on air handler and fan coil unit. And then they're going to run it, and basically, and they're going to see if there's any areas. This one, they got an error because I went and changed one of the fields to produce an error. So now they'll be able to see what they errored, and it'll tell them that there are no elements in the model that meet air handler because this type is air handler unit, and they made a mistake with the naming of that particular asset. Changed it, and now there's no errors, everything's passed. So it was custom for us because it was more critical for the equipment that they got all the information on the equipment asset right versus other things. So that's how our model checker works. So I'll turn it over to Joe. Okay.
All right, thanks. All right, so I do want to say what's really fun for me is that Western Michigan was way before us when it came to modeling their campus. So for me, it's a lot of fun to be able to be up here and talk to you. When we first started in 2010 modeling, they'd already been doing this for about a year. So Western Michigan is who Ohio State wants to be when we grow up. So they're way ahead of us, and they're doing some amazing stuff that makes me jealous all the time. But I want to talk to you real briefly about how we actually use the model checker. And we're using it in kind of a different way because we have a little bit different requirements on what we're expecting. And we're using it in two different ways, too, which I'll talk you through. First, he already kind of showed you this, but the model checker, you start by configuring it. As he already mentioned, at the top you see our external model checking rules and his. But what I'm going to talk to you about first is how we use this tool internally for checking our internal models. So as you know, we've been building our models for existing facilities. And so we actually use two different model checkers to help check our models. One is Celebri Model Checker, which is an IFC-based model checker tool. And it has some limitations because it primarily deals with geometry. And while that helped us a ton in getting away from a purely visual audit, it had a lot of issues in that it didn't check anything within the model itself that was Revit specific. And so when Revit Model Checker came along, we immediately realized we needed to start using this to kind of fill in a lot of the gaps that we had. So we have an internal model checking rule set that CAD Microsystems helped us build out. And I'm going to kind of talk you through some of the things that we check within this model check. First thing when primarily the students at first use this is that they're going to go and set the scale. And so since each one of our models might be built to a slightly different scale, they're going to go in there and they're set that value right there. And then they're going to go through all the different sections. We do not let them uncheck any section, so they have to check everything. And here's some of the things that the model checker can check for us. What is interesting is this is not the only thing that the Revit Model Checker can check. We just have picked the things that matter to us. But we check for things like unplaced rooms and spaces. And do we have any redundant room numbers? Room numbers have to be typed in by hand, and so there's oftentimes errors there. Did you put the same room number in two different places? We don't want the word room or space to be in a room or a space. I know it's very particular, but we don't want it there. We want them to delete it. And are the room numbers a valid number, meaning if they have to be between 3 and 4 digits long? Is the space ID, which is our unique identifier, for that room, is it created correctly? And is there a building number parameter? Also, then when you get into floor plans, we're looking at things like view types and naming conventions. What we did for naming conventions is we basically said, like DeVon did, here's a list of all the valid names that a floor can have. And if it's not one of these, then it's wrong. And so even simple, really simple spelling errors are hard to check visually. So having a tool like this that instantly can check, did I spell even all the rooms correctly, really helps us out, because those have a lot of downstream issues. You heard about me talk about this before. There's a lot of automation built into our environment. And if a floor name is spelled incorrectly, it's going to have other issues for us downstream that we're not necessarily going to catch until later. So do we have, are view types correct? Are the naming correct? We have this, in all of our windows and doors, we actually have two little check boxes. One says interior and one says exterior. And we want to make sure that one of the other is checked and not both and not neither. So there's a little check for that also. We want to make sure that templates, they're using the correct templates. Ceiling plans, similar things. Are they using the correct types, the correct naming conventions? 3D views are very similar, but we also add that we want to ensure that our section boxes are pinned, and it can check for that too, and that our 3D views are locked. We don't want those to be accidentally moved around later. Elevations are similar, naming conventions, pinning. We also want to make sure our crop boundaries are turned off. Sections are also similar to that. And then we get to our area plans. We have some specific naming conventions around our area plans. We want them to be called gross area, which is not a standard out of the box. We want to make sure that the tag associated with that area is correct. And then sheets, the same thing. Do we have the valid sheet names again? Back to that same list. Is this a valid sheet name? Along with making sure that that all the viewports are pinned and that the annotation crop is actually turned off in this case. We also look at all the families that are in the model. This is more of an informational view for our BIM coordinator and also for the students. First thing is looking at unused elements. If there are a lot of unused elements, you probably have to purge that model. Now, we're not going to get rid of 100% of them usually, but this is an instant we can look at it and say, hey, there's a lot of them in there. We need to probably do something. And it also has a quick look at our system families and our detail items. Again, this is more for the BIM coordinator, for Tracy, who you've met her, if you've met her, to look at kind of a quick view of the whole model and understand, is there some weird naming conventions in there? Are there things that I should not be seeing in this model without having to dig through maybe another schedule or dig through a list of families? And then from a naming convention, we want to ensure that all of our different types of families have the prefix OSU underscore in front of them to ensure that it's one of our families that we've developed internally. And so this is a quick check to make sure that everything in there, it passes that, and if it doesn't, it's going to say, hey, you've got this family that's named incorrectly. It should have an OSU underscore in front of it. And also, we don't want any generic models in there, so it's going to throw an error if it sees any of those. And then lastly, we want our process is to bring that AutoCAD and actually link it in and use it as kind of an underlay as we're drawing our drawings, or we're building our buildings, I should say. And so we want to make sure those are all removed before we complete that model. So checking to make sure that those have all been removed. And then also all the material names also have the OSU underscore included in them. So that was our internal rule check. And even as DeVon mentioned, we're giving this rule check to others to run. So in our case, we gave the students this to run. And they should get a clean report before they turn it over to our BIM coordinator. But Tracy's going to run that again just to make sure that they did it all correctly. And then we have that same expectation, though, with our external partners. And we just released this to our external partners here at the beginning of this year. We worked with CADD Microsystems. They actually developed it a little bit earlier than that, but we finally released it with the third version of our project delivery standard. And we use it in a very similar way to the way that Western Michigan does, in that we're not going to go in there and do all these checks ourselves. We actually have it in our project delivery standard that they will just give us a copy of that report. So if they have any deficiencies, they're going to send us a report that has those deficiencies. Sometimes they have a question, like, I don't understand why I got this deficiency, or this deficiency doesn't make sense in this particular situation. So, but they're expected to go ahead and run this external rule check that's just for projects that are being delivered to us. And it's a very different rule check than the one that I just showed you. If you notice, the way that we actually numbered these is that it actually lines up with the sections in our project delivery standard. It makes it easy for them to find where these problems might be from. In addition to this, we can't use the Revit model checker to check everything in our project delivery standard. That's true probably for both of us. It's checking a certain number of things that we can automatically check, but this definitely simplifies that process. So the first thing is we don't want any area plans to be in there. We want to make sure that gross building type the area plan is actually of a gross building type, which is similar to what we have internally. And we also go back to this room number issue. Do you have all valid room numbers in there? Now, we do all room numbering for our projects, but it does not mean that our project consultants and partners actually did it the way we told them to, or didn't add an extra room in there because they added an extra room and didn't ask us about it. So we are checking for valid room numbers. It doesn't necessarily mean it matches exactly what we did, but at least we know that they're using our standard format. We also check for, we don't want any revisions left on the models that are turned over to us. So we ensure those have all been rolled up. We also only want either existing or new construction as phasing. So we don't want any demos or any other types of phasing. So checking to make sure that that's been cleaned up before they give to us. Now, if you think about some of this, if they're running this check and they have to deliver it to us several times during the project, early in the project, this might fail, and that's going to be okay, because it's going to be early in the project. They might have a demo layer, and we're okay with it. We understand that when we see that. But at least by the time, when they give us the last copy of this, when they're ready to turn over the model, this is one of those checks that should pass. In addition, we've all had the situation where you come across, there's this room that shows up in a schedule, but you have no idea where it is, or it says it's not placed. We want to make sure that all the rooms actually have an actual space associated with them, that all the other spaces have been cleaned up. Now, if you notice, I didn't go through the COBie part there, and I'm only going to mention that very briefly. There's a bunch of checks in here to ensure if you're using the COBie Toolkit, which we actually do require folks to use, but they don't use it until much later in the project, you can actually check this, and it'll actually ensure that all the COBie parameters are set up correctly. Now, if you've used the COBie Toolkit, generally speaking, that's going to pass okay, but this is another optional check that they don't need to check necessarily. This section here is all about different fields. We want them to add a couple of fields to the model that is not out of the box. And so this just ensures that these fields actually exist in the model and that they've entered some sort of data in those fields. And then, not lastly yet, but we also want them to add correct GIS coordinates into the project base point. And what we've done is we've said, if you're on main campus, you need to check the first one. And it'll say, look, if you're within this lat long by this lat long, then you're probably right. We can't get any more accurate than that. But at least you're in the right campus for your GIS coordinates. And so whichever campus you're on, you're going to check that one when you run the model checker, and it'll let you know that you at least got it into the right part of our state. You may not have got any more accurate than that, but we can at least say that. And then back to this level naming convention, just like our internal rule set, any project that's done for us has to meet that same level naming convention. And so we have a long list. I'm going to show you in a second how that works of valid names. And when they run this, if a name is not on that list, then they're going to get a warning and say you can't have that level in your project when you turn it over to us. Now, this is the configurator, and I just wanted to give you one slide just to give you a little feel for what this looks like. This is how you build a rule, and since this is not a training session, I'm not going to tell you how to do this, but you can see over here, here's all the valid level names, and this goes down a lot further than this because we have probably about 50 or 60 valid level names, but this is how you would build a rule. You'd say these are the valid options, and this rule is going to check, is that level one of these valid options? And so every rule kind of has this type of look to it. Now there's some optional checks. And these checks are kind of default out of the box available. We don't require them to be run, but they are best practices in many cases. Checking for things like are there any generic models? Shouldn't have generic models or groups. But we're not requiring these things to be done because these aren't part of our standard. They're just simply best practices that they can run if they'd like to. So once they've actually, that was kind of when you first started up and you got the configuration part. In general, they're not really going to do much of that step. I've just kind of gave you an overview of the pieces that are there. They're going to leave everything checked that's checked out of the box, and they're going to come run the check. And you're just going to simply come in here and say run reports, and they're going to get something like DeVon showed you already. In this case, you'll see that this model had some floor plan issues and some 3D issues. But what's really nice about the model checker, especially for when we're dealing with this with internal our internal process is that for a lot of the checks, if it fails, it's also going to give you a really easy way to go find that error. So if you notice, there's a show button right here. And when you click on that show button, it's going to immediately take you, if it can, which if it has a show button, it usually can, so to where that specific issue is. If you notice, this is a view set. This says views do not match the set scale, and it took me right to the place to say this is what the view is set, the scale that it's set to. This makes it really easy to find things. And one of the challenges with for us is using something like the COBie model checker tool is that it's a disconnected tool. It's using an IFC. And so you see an issue there, you gotta go try to find it in the model. And so this is really nice because it immediately takes you to where the problem is actually at. Example here again, that these levels or grids are not pinned. It's taking me directly to the level in question. You can immediately find the issue and they can go ahead and correct it. Here's an example of one of those reports. Here's your unused elements and your system and your detail item list. And then that was for internal. For external, similar report. What they typically do then, what we had them do is they run this model check, and then they, on the upper left-hand corner, you'll see export HTML. They'll simply export that, and they'll email it over to us. And that's the way that we actually review, are they being compliant to this point in the project with our expectations? And then we can kind of talk through any issues that they might have and we might be seeing. So that's all I want to talk about with the model checker. I just wanted to give a quick plug also that we use the COBie Toolkit, which is part of the tools that the TG already mentioned. We found that this, for us, is the best way to get the data initially out of the model. We actually have the AE, towards the end of the project, export out a COBie spreadsheet of all the data for all the models, and then we take it and run a macro on it to make it a very simple spreadsheet, because COBie, as most of you may be aware, is very complex. It's hard to kind of work with. And then we turn it over to the contractor, and they fill in a lot of the more timely information, like serial number, exact model number, warranty information, that type of thing, and then they hand it back to us. But we found so far that the easiest way to actually get that initial list of equipment out of the actual models is to use the COBie Toolkit, but then convert that for easier use for our contractors. That's all I've got.
So why don't we open up to questions? Does anybody have questions for them? Yes, sir.
Question for Joe. With the buildings that you've scanned and you have kind of a shell in place, when you go to remodel one of those buildings, and this kind of multi-parts of this, are you giving them your base Revit model to work off of? And then, if so, how do you reconcile any deviations between, a CAD file that might have had errors and that Revit model, and then, kind of take that forward? Like, if you're doing a partial remodel of a building, how much are you asking them to do, and how do you, kind of quality check that?
Okay, so let me make sure I understand the question. So are you asking if they're doing a project based on a model we already built? So we built a model for a building, and then they're doing a project in there, and they're going to take our model, and then they're going to do something with it, and then return it back to us. And kind of how do we handle that process, essentially? Is that what you're asking?
Yeah, if that is the
Yeah, so I think the best way for us is what happens typically is while they may take our model, oftentimes they're probably using it more as a reference than they're actually updating it and passing it back to us. And primarily this is all around the issue of indemnification. We really can't promise that our model is perfect, so they basically say, well, because you can't, we're going to start from scratch and build our own, because that's the only way we can be safe about it. So they might use it as reference. So the process would be, but if they did a partial renovation, we're just going to simply bring that piece back in, and then depending on how big the renovation is, if it's a full building renovation, we're probably just going to, we had an example of this, we built a model, but it was a full gut of a building. We're basically just going to scrap that model, it's going to be archived, and we're going to take their new model and run what we call our BIM to BIM process on that, which is a cleanup process we use to take that model and bring it into our environment so it matches all of our CAD to BIM buildings. If it's a partial, that all depends. If it's really small, maybe we're just going to use it as almost a tracing tool. Otherwise, you might just cut out the part and bind in the new Revit pieces. If you really want details on technically how we do that process, right there on your row, you can talk to Tiffany, because she will tell you exactly how we do that if it's a partial renovation, because she's had to deal with that a couple times already. So,
I want to add to that too. We've helped a lot of owners develop that process, and there's actually a way you can do it with Revit, where you can maintain a master model in Revit and give outside consultants part of that model, and then anybody in-house will know, oh, those parts have been given out for a separate project. So if I need those parts, I better go talk to that PM and figure it out. And then it gives you a nice spot to swap back out when it does come back in. So if you want to learn more about that, you can, I can give you my card.
I'm thinking, this can be for any of you, but I'm thinking of some buildings that maybe are different or an anomaly. Like we bought a building and the room numbering doesn't follow the standard, but we can't renumber the whole building. So the model checker has to ignore that part. So do you have anomalies that you just let slide? Or do you handle it another way?
Okay, trying to remember how I repeat the question there. So I think the question is, do we have, if there's any anomalies, do we ignore those? So from an equipment standpoint, the model checker, how we have it is, it's still gonna be up to us to go through and verify some things, because like I said, the model checker is not gonna know if they put in the model number wrong or something like that. It's gonna see to make sure it's not blank, but things of that nature. So there's gonna be some things you may have to ignore, but for us, we just wanna make sure that they're at least attempting to put in the information that we asked for. That's one of the reasons why I mentioned that we brought a commissioning agent involved in the BIM process, because they're already out there taking account of all the equipment that they're functional testing, so they're gonna see what the serial numbers and the model numbers, and they can help verify that the information that the contractor's putting in there is actually valid. So that's kind of how we're offsetting that. So the model checker is just a tool to say, hey, at least I went through and it passed. Now I can turn it over to you guys to do what you guys need to do with your CMMS. I hope I answered your question.
Yes.
Yeah, I think there's always some anomalies, I think, sometimes, especially if it's an older building that we couldn't, remember, I have a longer story, but it's really long. It's not necessary to talk about. But I just think there's sometimes those cases, but especially when buildings, if there's certain things in our model checker that is maybe, there might be some weird case. Sometimes you do let it slide, but that's typically not the case with the things I was talking about. Most of those things are things that they have to turn it over that way, and that's just the way it's going to be. So.
Any other questions?
TJ, I was going to ask you if you could talk about some of the things we're doing in the new version, in particular the Excel export.
Yeah, so
That's a big one for tracking.
since we're all under safe harbor, so the new version of the model checker is coming out, version 7 of that. The model checker's been around since 2011. This is not new software. So version 7 is coming out, could be any day now, to be honest. It's not a technical issue. It's a contractual one, so that will happen very soon. The new version will allow you to not only save the report in the model. I know Joe showed that they actually export to HTML and send it with the model. That report actually stays with the model. If you save the model after running the report, you can send the model and just open it up right from the model and not have to have a separate file. You can export as HTML. The new one will actually let you export the report to Excel. And the whole purpose of that is to actually plug it into some sort of analytics program. So what we're finding is a lot of people are using something like Tableau or Power BI, and they're plugging in the Excel spreadsheets every time they run a report, just throwing them into that folder. Those softwares will actually just read the folder and show a dashboard and say, here's how things have changed over time. You know, I've had more errors over time, or I've had less errors, or the file size growing, or whatever you're measuring over time. So the Excel exports will be a new feature with the model checker. We've cleaned up the reports a lot so that the reports actually will say, these are the past fails and how many failed. These are the lists of things that you've looked for. Here's the ones that show counts. Here are the ones that have errors. And gives you a detailed number count, not only of the whole report, but every section that you've made in the report as well, which is a new feature. And it's really nice. You can see the report and see, oh, I had 2 fails. Well, where are they? I just go down to the section headers and it says, well, there's a fail in this section. And as I drill down, each subsection header will guide me right to where that error is. And I can hit the show button and go find it very easily.
From an owner's perspective, it was really about adding the Excel export so you could track model progression over time, right? Because the whole goal of these tool set is to make model validation and classification an iterative process, not what I always call a punitive process. So you don't get to the end of the thing, run a model through a check, and then give your AE back a report of how bad his model is. It should be a constantly iterating process, and at the end, you just deliver a model. Well, with the Excel export and things like Tableau and Power BI, you'll be able to be requesting periodic model reports and then have a dashboard telling you how is it trending. I mean, right, we should be trending down in errors. We should be trending consistent in other areas. So that was a big initiative we asked CAD Micro to do for us on this next release to support that dashboard.
The last thing you want is to be surprised at the end of a submission with all these errors that you have to suddenly fix. And that's why you want to have your AEs and you as well as an owner continually check the model. Since it only takes 30 seconds to run the model checker, that could be your daily thing. At the end of the day, I'm going to sync to Central and I'm going to run the model checker and see what happens.
So to give you a scale on our COBie challenge model, which is what, about a 45,000 square foot office building?
I think it's about half that.
I'm sorry, but
Yeah.
it has about 40,000 parameters in it filled out. On my old laptop, it takes me a minute and a half to run a COBie validation model check against it. A minute and a half to know exactly where I'm at. When I demo the tool, I have a version of the COBie model that's missing a single door parameter. And I ask people, how long would it take you to find a single missing parameter in 40,000 parameters? And I find it in a minute and a half.
The Penn State model checker, which is free to everybody in downloads, has over 6,000 checks in it. It takes about 2.5 minutes to run on a decent sized model. That's a lot of checks. All right, so here's where you can get the tools. Again, BIMinteroperabilitytools.com. I show that to you because sometimes they're on the Autodesk website, sometimes they're not. The Autodesk website is constantly changing, and because of that, we just built this microsite to be able to everybody get to it. There are sample files on there. There are links to a whole YouTube channel. So every single one of the products has a whole bunch of 2 or 3 minute training videos on how you can use them. And then, of course, if you guys have any questions or want help with it, come grab my card. We'll gladly help you. We are about 4 minutes still, so if there are any more questions, I'll leave it to that. Otherwise,
One thing I do want to mention, so this has come up in a couple private conversations. The tools support the same versions of Revit that Autodesk supports. So current release and 3 releases back. So right now we're supporting 16, or 15, 16, 16, 17, 18, and 19. But the big thing is that the configuration files are consistent from version to version. So if you have a model check configuration in your Ohio State, someone can be doing a model for you in 16 and using your configuration. Somebody can be doing a model for you in 18 using the same configuration. So the configuration files are not version dependent. So that gives you a lot of flexibility in working with your AE community.
They're XML files, right?
The model checker's XML, the classification manager's XLS, the Microsoft spreadsheet.
and if you build your own model checks and you want to make it easier for your AEs to get that, you can hand it over to us and we'll post it actually in the software, just like we do with Ohio State and Western Michigan. And the next time anybody in the world opens the software, they will see your check set right there and can be able to use it. All right, any last questions? Very good. All right, we'll end it there. Thank you, everybody.
Thank you.